All right, the first thing we want to look at is some definitions. Our first definition is revenue. Revenue is another word for the total income or total amount earned when you're selling a product. So we can define that as the number of items that we sell, or the number of items sold,
times the price that
each item sells for, or the selling price per item. When you're in business, the thing you're thinking about most often is the profit. So let's look at what profit is. Profit is essentially the revenue minus the cost of the goods that you sell. So however much money you bring in minus however much money you sell your goods for. That's what you have left, and that's what you get to take home, or is your profit. The cost, or cost of goods sold, is basically your revenue minus your profit. So how much it costs you, or how much you bring in minus how much you get to keep, is the cost. Okay, another way of looking at profit is looking at the total number of items that you sell, and you multiply that by the profit for each item. So number of items sold times profit per item also gives you profit. During the summer months, Terry makes and sells necklaces for $10 each. His sales averaged 20 per day. Before deciding on an increase, he took a survey. For every dollar increase in selling price, he'd lose 2 sales every day. Each necklace cost him $6 to make. So we want to determine the new profit per item he would make if he increased the price such that he got the maximum profit. And what should the selling price of each necklace be to maximize the profit? First thing we need to do is define our variable. So we let x represent, again, the number of increases in price. So each increase is $1, so x represents the number of $1 increases in the price of the necklace. Once we've done that, we can set up a table to relate all the information we have together so that we can create our function. So first we look at the number of necklaces that we sell, and we look at the profit made for each necklace. Okay, we look at each of these variables at the old price, or the current price, and then we look at them as what happens if we change the price. So that would be at the new price. So at the old price, we sold every day 20 necklaces. Okay. At the new price, we've decided we're going to sell a few less, 20 minus 2x, because for each increase in the price, we sell 2 less necklaces. Our profit per necklace is our selling price, which was $10, minus the cost that the necklace is for us, which is $6, so our profit is $4. Our new price, we have $4, and then we add in X number of dollars because for every dollar we increase the price, it goes purely to profit. Now we can look at our equation relating everything together. The profit equals the number of necklaces sold times the amount of profit we earn for each necklace that we sell. Plugging in the information we have, we get that profit equals 20 minus 2x times 4 plus x. Once our equation is written in factored form, it's very easy to find the zeros. The zeros represent the y-intercepts of the equation, or the values where y equals 0, and that crosses the x-axis. To do that, we set either the first bracket equal to 0, or the second bracket equal to 0. Let's solve. So the first bracket, 20 minus 2x equals 0. Rearranging the numbers, we can find x that gives a value of 0, which is 20, over 2, or x equals 10. With the second bracket set equal to 0, again, we can rearrange. So we have 4 plus x equals 0. Rearranging, we can get a value of x equal to negative 4, which gives the entire bracket 0. Once you find the zeros, you can average them to determine the x-coordinate of the axis of symmetry, which gives you essentially the x value that maximizes our profit. So when we average our zeros here, we have 10 minus 4 over 2, which equals 3, and then that tells us that x equals 3 is our x value that will maximize our profit. Okay, what have we found? We found that x equals 3 is the value that will maximize our profit. But x represents the number of $1 increases in price. So therefore, to maximize our profit, we need to increase the price 3 times, or by $3. 3 price increases of $1 each. If we want to calculate the profit for each item, we go back and look at our original table. In our original table, we defined the profit for each item was 4 plus x. Therefore, our profit for each item is the $4 we made before, plus $3 because of our 3 price increases, or $7 per item. To determine our new selling price, we again go back to our original table. Okay, we have the cost of the item plus the profit we intend to make. So original cost was told to us is $6, plus we're making $7 profit, so we need to sell the new necklaces at $13 each to maximize our profit. Right, let's look at our next example. 30,000 bus riders every day pay a fare of $2.25. The city wants to reduce car pollution and get more people to ride the bus and maximize the system's revenue at the same time. A survey indicates that the riders will increase by 1,000 for each 5-cent increase in the fare. So we want to know an equation to represent the revenue, find the fare that represents the greatest revenue, and find what the maximum revenue is total. So we define our variable x, again, to let it represent the number of increases or decreases, in the fare that's being charged. In this case, each decrease is $0.05 or 5 cents. All right, now we set up a table to summarize our information. We include the information, our price for each ticket, and the number of riders that will be riding the bus. So at our old fare, we look at one value, and then we look at the value at our new fare. Okay, the old fare is $2.25 for each ticket. At that price, we have, our new fare is $2.25 minus 0.05 times x. In other words, we decrease the fare x times for $0.05 each time. At our old fare, we had 30,000 riders, but at our new fare, we hope to have more, at 30,000 plus 1,000 times each number of decreases, so 30,000 plus 1,000x. We can then set up an equation to represent our revenue, which is the total number of tickets sold times the price for each ticket. Per ticket. Looking at our table, which summarizes our information, we know that the number of tickets sold is 30,000 minus 1,000x, and the price for each ticket is $2.25 minus 0.05x. Multiplying those two together gives us our revenue function. Now that we have our revenue function set out, it's in factored form, and we can use that fact to solve for our zeros or our y-intercepts. So either the first bracket equals 0, which is 30,000 plus 1,000x equals 0, giving us 1,000x equals negative 30,000. Then we can solve for x. Negative 30,000 divided by 1,000 gives us negative 30. Now we can look at our second bracket and solve. So 225 minus 0.05x is going to equal 0. We rearrange to get 2.25 equals 0.05x. Solving for x, we get x equals 2.25 divided by 0.05, or 45. The average of our two zeros gives us the x value of our axis of symmetry, or the x that maximizes our revenue. So we take 45 minus 30 over 2 equals 15 over 2, or 7.5. So the x that maximizes our revenue is a value of 7.5. Okay, we've determined the value of x that will maximize our revenue, and that's 7.5. Going back to our original question, there's a few things that we want to check and see what we were asked. So the first thing we were asked was to determine an equation to represent the revenue. So that would be r at x, and that's what we've done here. And you can leave it in factored form. There's no need to change it into standard or vertex form. The next thing we need to find out is what new fare we will have that will give us the greatest revenue. So our new fare, by going back to our table, was 2.25 minus 0.05 times x. Subbing in 7.5 for x gives us $1.88. So the best fare to charge would be $1.88. Now in reality, it would probably be $1.90 because it's a little easier when we have things by fives, but this is what the math tells us. Then the last thing we want to find out is what the actual maximum revenue was. So we plug in the value of x into our revenue function, r at x, And we plug in the value of 7.5. So here we have 2.25 minus 0.05 times 7.5 times times 30,000 plus 1,000 times 7.5, which gives us our total revenue of $42,187.50. And that's the amount that Springville Transit would bring in every day if they decrease the price of the tickets to sell more.